Hello and welcome to the lecture of air pollution and control. Today we will discuss few things about the automobile exhaust. So the main types of automobiles concern includes passenger cars, which generally runs on four-stroke gasoline engine, then large buses and trucks, which even runs on four-stroke diesel engines, few motorcycles, scooters and auto rickshaws, which run either on two or four-stroke gasoline engine. Here gasoline means the engines run on generally petrol. Well, as far as the emissions are concerned, those are generally divided under three headings: exhaust emissions, crankcase emissions, and evaporative emissions. The major air pollutants included in exhaust from the automobiles are concerned. They include hydrocarbon, which generally are 65% from the exhaust gases. 15% hydrocarbons are evaporative from the evaporative gases, and 20% from crankcase. It even includes the different exhaust gases like carbon monoxide, nitrogen oxides, and different lead compounds exclusively from exhaust gases. Right now, we are in an era where generally the gasoline is lead free, so those things can be eliminated by the use of lead free petrols. As far as the diesel powered vehicles are concerned, they have relatively less pollution problems as compared to petrol run vehicles, where the amount of carbon monoxide is generally around 10% as compared to gasoline vehicles or petrol vehicles. Hydrocarbon emission is almost same as that of petrol emission. The evaporative emission is also low, but the major problem are smoke and odor. So this table is representing the effect of engine operative conditions on the composition of auto exhaust or exhaust gases. We have considered here the four cases of the engines when we are starting or idling, then when we are accelerating, then cruising, and when we are stopping or decelerating. So the general air fuel ratio in case of starting or idling is 11:1 to 12.5:1, which generally is in a range of 11:1 to 13:1 in the case of acceleration. While cruising, it increases to 13:1 to 15:1, and when we are generally applying the brakes, it is deceleration, and the ratio once again is almost same as that of idling and is in a range of 11:1 to 12.5:1. As far as the emission of gases is concerned, the carbon monoxide is 4 to 6% in at the time of idling, and when we are accelerating it is reduced, but can be in a range of 0 to 6. When we are cruising it is 1 to 4, and when we are braking it is in the range of 2 to 4. And other things like nitrogen oxides, hydrocarbons, unburned fuel, everything is mentioned and self-descriptive. As far as the exhaust emission is concerned, they are the functions of different things, which includes the air as to fuel ratio, spark timing, combustion chamber surface volume ratio, compression ratio, combustion chamber deposits, coolant temperature, and other operative vehicles like the application of brakes, the road conditions, and other things. This graph represents the emission of different things like nitrogen oxides, carbon monoxides, etc., and at the different air fuel ratio. Where the lean misfire region is supposed to be the idle, as the air as to fuel ratio increases, the carbon monoxide and hydrocarbon are generally produced in less content, while the nitrogen oxide generation increases at a ratio around 15.1. It is supposed to be the ideal condition for the emission of hydrocarbon and carbon monoxide, which is very less, and nitrogen oxide, which is comparatively less harmful, is at the max. So one should be very careful about the air fuel ratio. If the air fuel ratio is not proper, then the overall generation or the emission of different uh, air pollutants are more. We can control this exhaust emission by various ways. Those ways includes the modification in engine design and operative variables, and then even we can treat the exhaust gases by different ways like promotion of afterburning of pollutants. Use of catalytic converters are two major ways of treating the exhaust gas. We even can use the petrol injection, and we can be used by stratified charged engines. Methods to reduce the emission of different oxides of nitrogen includes the exhaust gas recycling, then the water injection into inlet manifold, exhaust manifold reactor with recycling, catalytic reduction, and lean operation. Well, the control of evaporative emission includes insulation of fuel tank, sealed and pressurized fuel system, as well as better carburetor design. So all these are the things related with the design of the engines, and this even provides a large uh, era of designing or modifying the current designs of the different engines. Right now you will find that there are different engine designs are proposed, and those modifications are generally in line with all these requirements. Other possible alternative includes the use of electric car. We will find that it is a thing which is currently has a buzz like anything, and everyone is running after the electric cars. Then we can use natural gas. We can use Wankel engine, which has more space available for emission control equipment. It can operate on fuel of low octane rating, and nitrogen oxide emissions are only 30% as compared to the conventional one. Then the gas turbines are there. Then ammonia fueled spark ignition engines are there, and unleaded gasoline powered engines are there. Thank you. I hope that this thing has been understood by you, and you can find much more things on this in the form of literature.